Hey guys, so in this video we're going to look at an electron address. All right, so we kind of spoke about this in the past. So we have the Bohr's model of the element. So here is just an example of Bohr's model of the atom. All right, and so we now know currently that the atom actually technically doesn't even look like this at all. All right, and reason being, so the nucleus is roughly the same. So the root nucleus is made up of protons and neutrons, and we know it's in the center of the atom. But the whole idea where the electrons are kind of rotating around the nucleus as like a planet is rotating around the sun, the whole solar system model, we know that's completely incorrect. So, and how the electrons kind of move about the nucleus, it's really kind of complicated, all right? But we're just going to best illustrate this as much as we can, all right? So like I said earlier, the protons and neutrons, yes, they are in the center, okay? But the way how the electrons configure themselves, it's just a little bit different. So let's just kind of talk about it. So what we do know is that the electrons are in what we call energy levels. Now, energy levels is just basically some proportion around, or some spot around the nucleus where we can find the electrons. And there's different energy levels, okay? Now, depending on the energy level, depends on the distance between the electrons to the nucleus, all right? And so when we say energy levels, sometimes some places, some people call them shells, all right? So we notate energy levels with an N, okay? And so when we say energy level is equal to 1, all we're talking about is the energy level closest to the nucleus, all right? And then it kind of grows from there. Then you have energy level 2, then energy level 3, oh, forgot that part, energy level 4, energy level 5, so on and so forth, all right? And so these are just energy levels, just places, this is the basic area where we could find the electron. All right. Now, energy levels are later on subdivided into what we call sublevels. All right. So much like how you could find cities within a state, we could find sublevels within energy levels. So there's 4 different sublevels that's typically found in all ground state atoms, okay? The sublevels are S, P, D, and F, all right? And I know those letters seem random, but it's really based off of the shape that these sublevels are in, all right? So lesson for another day. So depending on the energy level, depends on which sublevels you could find, all right? So for example, if we have energy level, all right, so once again, I'm just going to notate this N. So energy level 1, okay, so the first energy level, the energy level that's closest to the nucleus, the only sublevel that you could find in energy level 1 is the S sublevel, okay? In energy level 2, you will find both the S, and for the first time, you will see the P sublevel. In energy level 3, you will have the S, P, and then the first time you have the D sublevel. In energy level 4, we will have the S, P, D, and then F. All right, it kind of goes on with this trend. There are other sublevels, but once again, all the electrons of all the atoms that we know so far could fit within these first 4 sublevels, as long as the electrons are not excited. All right, and so what you see here, as you basically increase in energy levels, so as the energy levels gets larger and larger and larger, all right, you also increase the number of sublevels that you see, all right? And this is always the case. So just always know that within the first sublevel, all right, you always have S, and S always appears in every single sublevel. So S is in the first, it's also in the second, third, and fourth, all right? But for the first time in the second energy level, you have sublevel P. You find sublevel P also in the third, fourth, and so on and so forth. For the first time in the third energy level, we have sublevel D, okay? And so sublevel D also shows up in energy level 4, and so on and so forth. And then for the first time in the 4th energy level, we have sublevel F, all right? And then F shows up here. So once again, as I said, so you have energy levels. So you could kind of, if you want like analogy, energy level is like the state that we live in. All right. So we live in the state of Georgia. Okay. And now sublevels is like the city within the state. So we could talk about Atlanta. Atlanta is in the state of Georgia. So sublevels are within energy levels. Now within sublevels, all right, there's another subdivision within sublevels. We have what we call orbitals. All right. All right. So the term orbital is a little bit different from what we're kind of used to here. And so orbitals, once again, apologize. All right, it's a subdivision of sublevels. All right. So here we have the subdivision of sublevels, which sublevels are the subdivision of energy levels. All right, now, dependent on the sublevel, all right, depends on how many orbitals will you have. Okay, so for example, so for sublevel S, all right, sublevel S has one orbital. So anytime we're talking about sublevel S, there's only one orbital within that sublevel. Anytime we talk about sublevel P contains 3 orbitals, okay? Sublevel D contains 5 orbitals, and sublevel F contains 7 orbitals. And it kind of goes in that pattern, that trend. So the next sublevel will have, if you only guess, will be 9. The sublevel after that will have 11. So it kind of goes in this series of 2s, okay? Odd numbers, series of 2s. Okay, so what are the implications of this? So just like how we said that if we're thinking about energy level, so energy level is like what state that you live in, all right? And then if you think about sublevel, which talks about what city you live in, well, when we're thinking about orbitals, then we're talking about more specifically what street you live in, all right? So street is within the city, which city is within the state. So you could kind of think about it in that aspect, all right? So once again, just to kind of highlight this, all right, so you have the S orbital the S sublevel only has 1 orbital. The P sublevel only has 3 orbitals. D sublevel has 5 orbitals, and the F sublevel have 7 orbitals. Now, it turns out that within each orbital, okay, and always the case, all right, you could have a maximum number of 2 electrons per an orbital, all right? So these orbitals, that's exactly where the electrons stay, okay? So when you kind of think about it this way, so like when you say, okay, you have the S sublevel, right? So the S sublevel, well, we know that the S sublevel contains 1 orbital. Well, how many electrons could fit within the S sublevel? Well, only 2 electrons could fit, a maximum of 2 electrons, okay? We have the P sublevel, okay? We know that the P sublevel contains 3 orbitals. So maximum electrons that could fit in the P sublevel would be, well, 3 times 2 would be 6 electrons. If you have the D sublevel contains 5 orbitals, and so if you think about the maximum amount of electrons that could fit in the D sublevel, it would be 10 electrons. And then you have the F sublevel. So if you kind of think your way through this, there are 7 orbitals in the F sublevel. So what's the maximum amount of electrons that could fit in the F sublevel? Well, hopefully you guess it right. There are 14 electrons, okay? So kind of just to take this back. So we have, and it's going to kind of travel through here. All right, so remember, this idea of the Bohr's model, all right, of the atom, we know is completely incorrect. Atoms do not look like this whatsoever, okay? We know that electrons kind of travel through or in what we call energy levels, all right? And energy levels is just basically space around the atom. Now, the energy levels distance is kind of different depending on how close it is to the nucleus. So energy level 1 is the energy level that's closest to the nucleus, and it goes up in these increments in these levels. So energy level 1, energy level 2, 3, 4, 5. All right, so and just talks about the distance from that electron to the nucleus. And then we know that energy levels are broken down into what we call sublevels, all right? And the sublevels are basically just, as I said, just compartments within the energy level. And we have 4 different sublevels, at least 4 different sublevels that we're going to talk about in this class. There's S, P, D, and F. Dependent on the energy level, depends on which sublevel you can find. So within the first energy level, you can only find the S sublevel. If the second energy level, you can find both S and P. The third energy level, you can find both S, P, and D. The fourth energy level, you can find S, P, D, and lastly F. Okay. Now, within sublevels, it's also broken down further to what we call orbitals, all right? Now, orbitals is just the actual space that we could find the electrons. Now, depending on the sublevel, depends on how many orbitals it contains. So within the S sublevel, there's only 1 orbital. In the P sublevel, there's 3 orbitals. D sublevel, there's 5 orbitals. In the F sublevel, there's 7 orbitals. And we know that per orbital, you can only have a maximum of 2 electrons, okay? And so when you think about this altogether, the S sublevel will have the maximum, because the S level has 1 orbital, you can have a maximum number of 2 electrons. Because the P sublevel has 3 orbitals, we have a maximum number of 6 electrons. Because D sublevel has 5 orbitals, you have a maximum number of 10 electrons, and because F sublevel has 7 orbitals, then you have the maximum number of 14 electrons. So there you go. That's the electron address.